Here for part A, let's first note that V initial equals, here we can say V initial is 110 kilometers per hour. Let's just convert really quick, 1,000 meters per kilometer. And then for every 1 hour, there are 3,600 seconds. This is giving us 30.56 meters per second. Now, at this point, we know that here, if there is, we have its time interval of 2.0 seconds. We can say that the distance between the two cars was 25 meters. We can say delta x of us, or u essentially, of the car would be 61.11 meters. And then delta x for the police car would be equal to 51.11 meters. We know that here delta x of both of the cars here would be 10 meters. So essentially, you have decreased the distance between two cars by 10 meters. The initial distance was already 25 meters. So here, we can say the new distance between cars would be 25 minus 10, or we can simply say 15 meters. So this would be the new distance between the cars after a time interval of 2.0 seconds. For part B, we're going to add 0.4 seconds to the considerations of part A. So here delta t is equaling 2.4 seconds, and during this time, we can say that you're traveling 73.33 meters, and the police car that is decelerating has traveled 58.93 meters. Now here, the initial distance between cars, d, is equaling, again, 25 meters. But now d new is going to be 10.6 meters. So essentially, 73.33 minus 58.93 is 14.4, and then 25 meters minus 14.4 is, of course, giving us 10.6 meters. So 10.6 meters is the new distance between you and the cop car. Now, at the start of your braking, let's call this T initial. So start of braking for your car. We can say that here, the speed of the police car is at T initial is going to be equal to 30.56. We can say, we can simply say velocity of the police car at T initial. This would be equal to 30.56 minus 5 times 2.4. This is equaling 18.56 meters per second. And we know that collision occurs at time t, so we can say at time, so at t, simply, the x position of the police car is equaling the x position of your car. So essentially, we're going to choose such that your position is x equals 0, and the x position at t naught, we can say x of u at t naught is equaling 0 meters, and then we can say x of the police at t naught is equaling 10.6 meters. So essentially, again, 10.6 meters, 10.6 meters, because that would be our new distance between the two cars. So now we're going to apply equation 215, and we can say that the x position of the police car minus 10.6 would be equal to 18.56 times t minus t initial minus 1/2 times 5 times t minus t naught squared. We can say the x position of your own car, is 30.56 times t minus t initial. And then here it would be minus 1/2 times 5 times t minus t initial squared. Now we're going to subtract the two equations. By subtracting, we find that here 10.6, this would be equal to 30.56 minus 18.56 times t minus t initial. And we simply solve and say 0.883 seconds equals the difference in time. So at that time, your speed is going to be 30.56 plus the acceleration times t minus t initial, and this would be equal to 30.56 minus 5 times 0.883 seconds, and this is approximately equaling 26 meters per second. So essentially, you're traveling 26 meters per second to hit the cop car. If you wanted to convert, this is approximately 94 kilometers per hour. So actually going quite fast when you hit a car. That is the end of the solution. Thank you for watching.